They detect repetitive radio signals transmitted from an Earth-like planet. A team of astronomers has detected a repetitive radio signal that has led them to a planet with similar characteristics to our own, located 12 light-years from Earth. That signal, say the researchers, suggests that the planet may have both an atmosphere and its own magnetic field, something that has not been detected so far on planets similar to ours, and that may help us detect them in the future. A planet's magnetic field is a shield that prevents particles arriving from its star from wearing away the atmosphere, explains Sebastian Pineda, an astrophysicist at the University of Colorado Boulder, and one of the researchers who made this discovery recently published in the journal Nature Astronomy. Whether or not a planet survives with an atmosphere may depend on whether or not the planet has a strong magnetic field. Pineda and his colleague Jackie Villadsen observed strong radio waves coming from the star YZ Ceti and the exoplanet YZ Ceti b orbiting it. The researchers detected them thanks to data obtained from the Carl G. Jansky Very Large Array Telescope Array in New Mexico, and their conclusion is that the signal comes from interactions between the magnetic field of YZ Ceti b and its star. "We saw the initial outburst and thought it was beautiful," says Pineda. "When we saw it again, it was very indicative that, okay, maybe we really do have something here." A new method for detecting exoplanets. For the electromagnetic waves produced from the interaction of a planet of the dimensions of ours and its star to be detectable at long distances, they must be very intense, the researchers say. Although we have already seen magnetic fields on massive exoplanets the size of Jupiter, doing so on an Earth-sized exoplanet requires a different technique. Magnetic fields are invisible, so it is difficult to determine whether a distant planet has one, explains Professor Villadsen. "What we're doing is looking for a way to see them. We are looking for planets that are very close to their stars and are similar in size to Earth," notes the researcher. "These planets are too close to their stars for you can live on them, but because they're so close, the planet is going through a lot of stuff coming out of the star. If the planet has a magnetic field that is traversed by enough stellar matter, it will cause the star to emit bright radio waves." YZ Ceti and its exoplanet are, according to the researchers, an ideal pair for this type of study because the planet is so close to the star that it makes a complete orbit in only 2 days. Much less than the 88 days it takes for the closest planet to the Sun, Mercury. As YZ Ceti b orbits its star, plasma from the star collides with the planet's magnetic field, bounces off and interacts with the star's magnetic field. This produces a series of reactions that create and release strong radio waves that can be detected from Earth. By measuring these radio waves, the strength of a planet's magnetic field can be determined. "This is giving us new information about the environment of stars," Pineda said. "This idea is what we are calling extrasolar space weather. Northern lights on a star." As we recounted in the first episode of Control Z, The Great Storm, the extreme solar activity that gives us such mind-blowing spectacles as the northern lights can grow in intensity to the point of frying Earth's electrical systems, crippling our civilization and sending us back to the Dark Ages in one fell swoop. Scientists imagine that interactions between YZ Ceti and its planet also create an aurora, which in this case would take place on the star. "We're seeing aurora on the star, that's what this radio emission is," Pineda explains. "There should also be aurora on the planet if it has its own atmosphere, a solar loop rising hundreds of thousands of kilometers above the sun." Both researchers agree that although YZ Ceti b is the best candidate for a rocky exoplanet with a magnetic field that we have seen, we still have research to do to be sure. "It's very possible that this is it," Villadsen says. "But I think it's going to take a lot of follow-up work before a really solid confirmation of radio waves caused by a planet comes out. There are a lot of new radio facilities up and running and planned for the future," Pineda says of the possibilities for future investigations. "Once we show that this is really happening, we can do it more systematically. We're at the beginning."